have our assistant up on the board. We're going to compare photosynthesis and cell respiration. We just, thanks to Gary in the back, we have the equation for cell or photosynthesis. Would you mind writing the equation for photosynthesis? Oh yes, I'm recording this, by the way, and I'm experimenting with my microphone. So if you guys all know the equation for photosynthesis and cell respiration, it's pretty simple. As she's copying this down on the board, just really think to yourself, if you were given a plant, what would you do to just not kill it? What does a plant need to survive? Okay, you give it carbon dioxide, talk to it, or it gets carbon dioxide from the atmosphere, water from the ground, and in turn, it's going to make sure you put light, probably add light right above the arrow there. Carbon dioxide from the air, water from the ground, and with lots of light, we're able to convert that light energy into this molecule, glucose, and add oxygen also. Put a plus O2 after the glucose. Yeah, plus O2. Yeah, it's not completely synced. There we go. Perfect. Thank you. So that's cell respiration. All right, now we've made this energy. We made this energy molecule. We have now converted all the light energy into a chemical form of glucose. Food. Yummy. Yummy food. I like to eat, so this is really good that we've made food. Now what? Now what? How's this little doggy going to get his or her food? How's it going to get the energy? How's the doggy now going to get the energy that the plant just made? Eat it, okay? So we have another equation that talks about how other organisms that can't convert light energy to chemical energy, we have another equation that describes how they get their energy. Any volunteers to write? The cell respiration equation. Now, hopefully, if you've looked, how is the cell respiration and photosynthesis equation similar? They're backwards. I know it's a little off. Just do your best. The bottom part is really weird. Yeah, just do your best. That's fine. So glucose. Yeah, I'll have to sync it later. This is my experimental recording, so there's probably a 99% chance that I'm not going to use this.
Close your eyes to write better.
No, but okay.
Continue.
There we go.
Plus. Oh, there's like 3 O's.
Okay, yeah, that's okay. That's okay. We get it. That's all right. We'll have to sync it here in a second. That's all right.
It's the equation.
Equation. All right. It's the exact opposite. It's just photosynthesis backwards. All right, so do you have to memorize each of the two equations? No, just memorize one of them and remind yourself it's just the opposite. So the doggy eats food and it breathes in oxygen. It gives off carbon dioxide and it makes a little bit of water. And the key part in the end is that it makes a molecule called ATP. That's the point of cell respiration, is to convert the food that you eat and the oxygen that you breathe into a more usable form of ATP. That's what cell respiration is all about. That's how we get our energy. Right? So when I eat my sausage egg McMuffin for breakfast every morning, right, my body's going to break that down, and all that glucose down to making ATP that I can use for the rest of the day, as energy for the rest of the day. Anyone else like sausage egg McMuffins? Nobody? Really?
I like them, they're yummy. I like their chicken.
They're so bad for you, but they're so good. All right, taking a look at the screen here. I'm going to use my little pointer. I'll go ahead and draw this. This again is just a diagram that shows the relationship between the two processes. So you have sun. Right, what comes up from the ground? Isn't that neat that I can just draw? Water from the ground, sun from the... And what from the air? CO2. Goes into the plant. The plant makes oxygen gas and glucose, which just so happens to be exactly what this little doggy needs. Breathes in oxygen, eats glucose, gives off carbon dioxide, does give off some water, but we don't have that there. Unless it actually goes to the bathroom in the ground, and then the tree's going to get its water and other nutrients, but that's another conversation. But this is the relationship between the two. All right, going up to the top here, I asked you to fill in this chart. Let me zoom in a little bit. Number one. Number one is what on the diagram? Number two. What structure is that? Chloroplast. So, there we go. Number three. What is given off? What is given off that is used for cell respiration? There we go. Number four, that structure is mitochondria. Number six, what is that? ATP. Whoops. Seven, anytime we break apart things for energy, anytime we do a energy transfer, some energy isn't really lost, but it is turned into heat. Five, of course, we give off carbon dioxide and water, which is what?